the Coulomb's law, and we have solved few numericals on Coulomb's law, right? Okay, today in lecture 12 we will be seeing the electric field intensity. What is electric field intensity, and we will try to derive what is electric field intensity due to point charge, and we will solve few numericals, right? Okay, we will take the help of Coulomb's law in order to derive the electric field intensity due to points. That we'll see it later. Okay, first of all we should understand what is electric field intensity, and it is represented by letter E, right? Actually we have to write like this. If I want to write E vector, put bar over it, right? Okay, before defining electric field intensity, I will make you familiar with two terms, that is source point and field point. Okay, I have a charge plus Q, right? It is having field everywhere in all the 360-degree directions, right? Yes, this we call it as lines of force, or field lines, or stream lines, right? There are several names: lines of force, or field lines, or stream lines, right? Okay, so this charge plus Q can be called as source point because it is the source for the field, right? So what is the source for the field? That is plus. Here the charge plus Q is the source of the field, so hence we call it a source point. Then I will consider one more point, some distance away from the charge Q. Let me take point A. I can take point B anywhere. A can be near to it or far away from it, right? Let me locate point A here. Then I will consider one test charge here. Means I want to, at point A, I want to find out what is the electric field intensity. Already we have seen, right? As we move far away from the charge, the intensity of the field goes on decreasing, right? Okay, as the point A moves nearer to the charge Q, that is source point, then the force experienced by this point A will be more. If the point A is moved away from the positive charge, then the force experienced by this charge will be decreasing, or it will be very less, right? Okay, let me place the test charge because I want to define what electric field intensity. So let me place the test charge Qt, whose magnitude is 1 coulomb, right? This is the test charge at point A. Then I want to find out what is electric field intensity at point A, where the test charge is located, whose magnitude is 1 coulomb, right? So we can define, and this we call it as field point. Okay, where we are placing the test charge, we call it as field point because I want to find out the intensity of the electric field at this point A, where test charge is placed. So we call this as field point, right? And source point. Source point is responsible for generation of the field, and field point we want, where we want to find out the effect of the field or intensity of the field, right? Okay, I hope you are clear with the two terms, source point and field point. So I will now always I will be using these two terms frequently in my lecture, right? Okay. Next, we can define the electric field intensity E as the force acting on unit positive test charge. Let me assume, right, since it is plus 1, so it is repulsive force, the force acting on it. Let me call, right, this is the force acting on the unit positive test charge. Let me call it as Ft, force acting on the test charge Ft, right? Then I want to define electric field intensity E, means the force acting on unit positive test charge, we call it as electric field intensity. This is the mathematical definition. So the force Ft acting on unit positive test charge, I call it as Qt, right? So this we call it as electric field intensity, the force acting on the unit positive test charge, Ft by Qt. Then practical units of electric field is volt per meter, practical unit, right? If I look at this equation, I can write it as Newton per coulomb, but the practical units of electric field intensity what we are going to use is volt per meter, right? This keep in the mind. Okay, we have defined what is electric field intensity. Then next, we will try to derive the expression for electric field intensity due to a point charge, right? Here use Coulomb's law. This will not be given, just for hint I have written here. So we will try to derive the electric field intensity due to a point charge, right? So let me consider the source point, right? I will locate first Q. This is the source point. Then I will locate the test charge here plus Qt. Is it fine? It is situated at some distance r. Then the force experienced by this charge, I will call it as Ft. and it is separated by a distance. Okay, instead of q, let me call it as q1, so that it will be easy for me to make use of connotations. So the distance vector between 2 points, that is where charge q1 and qt are placed, the distance vector is r1t, right? And unit vector is a1t in the direction from 1 to t. Yes, we know we can make use of Coulomb's law. By Coulomb's law we can write the force exerted on charge qt by q1. The force exerted, okay, let me write it. Force exerted on charge qt, qt is the test charge, by q1 is given by ft is equal to, right, we know it is multiplication of the magnitude of the charges q1 into qt divided by 4 pi epsilon naught r1t square, the distance between the two charges, r1t square into a1t. This we know. Yes, this qt I will take it to the left hand side, ft by qt, right? So I will take it to the left side, ft divided by qt. I am moving it to left hand side. What I am left out with RHS, I will write it here, q1 by 4 pi epsilon naught r1t square into a1t. But by the definition of electric field intensity, we know that the force acting on the unit positive test charge is electric field intensity E. We have defined it, right? This is the definition. So finally we can write the electric field intensity E due to the point charge is E is equal to q1 by 4 pi epsilon naught r1t square into a1t, right? This is the electric field intensity E due to the point charge. Yes, and unit already I have told, practical units is volt per meter. Yes, the distance between the two charges, if I take it r, right, instead of writing 1 to t, just I want to find, right, I will rewrite the equation here, the above equation. You can observe here q1, this is the source point, this, right, q1 by 4 pi epsilon naught, instead of writing r1t, the distance between the two charges means source point to field point, the distance between source point to field point, this is the field point fp I am writing here, right? If I take it as r, simply I can write r square, and unit vector is ar, simply I can write it like this. Is it fine? Both are one and the same, the two equations, right? Okay, I hope you have understood this. What is electric field intensity? We have defined it, and we have derived the expression for electric field intensity due to a point charge using Coulomb's law. The next, the same continuation of that is electric field intensity due to a point charge. The analysis in spherical coordinate system means, what I will do, I will consider the source point at the origin of a spherical coordinate system, then field point on the surface of the spherical coordinates. Okay, we'll see it, and we will try to analyze how the formula will change. Already we have this formula here. The electric field intensity due to point charge is given by q1 by 4 pi epsilon r1t square into a1t. Then if I make use of the spherical coordinate system, how the formula will change, we'll see. Okay, I will consider the sphere here. At the center of the spherical coordinate system, I will consider the source point. Let me call it as q1 or q, no problem, q1. And the surface, I will consider the test charge qt on the surface. The distance between charge q1 and qt is the radius of the sphere, right? So I will make use of the position vector r vector. This is origin, right? Origin of the spherical coordinate system. Then the test charge is on the surface of the spherical system. It can be located anywhere on the surface, I have considered here. And the position vector I am making use is r vector, this, right, r vector. And the unit vector is ar vector in the direction of the radius. Then I want to write down the formula. So the electric field intensity, already I know the formula, right? So the source point is q1 divided by 4 pi epsilon naught. What is the distance? R square, right? So it is position vector magnitude, right? R square into AR vector, right? If I make use of the spherical coordinate system, this is the way how we can write the formula. And general formula I will write E is equal to, see here, the spherical coordinate system means the unit vectors are AR, A theta, A phi, but A theta, A phi are absent. Only I have the radial component of the field, not the theta component and the phi component. Only the radial component of the field is present. So I can write this as ER into AR. Is it fine? ER into AR. E theta and E phi are absent here. They are 0. What is ER here? ER is Q1 by 4 pi epsilon naught R square into AR. Right? So just we have seen the slightly modified formula. If I consider the source point at the origin of the spherical coordinate system, this is the source point and this is the field point. SP stands for source point, FP stands for field point. You should be very much clear. Source point is responsible for generation of the electric field, and the field point where I want to find out the effect of the electric field at that particular point due to the source. Next, I will continue the same study, the electric field intensity due to point charge, but now we will carry out the analysis in rectangular coordinate system, right? So here what I will do, here we will try to locate the source point at the origin of the rectangular coordinate system. Okay, just I will take the help of the rectangular coordinate system. I will draw it. Three-dimensional rectangular coordinate system, x-axis, y-axis and z-axis, and I have the origin here where I will locate my source point. Let me call this as Q1. This is the source point. Then away from origin I will consider some test point, right, or field point, and I will place the test charge QT here. So this is the field point where I want to find out the electric field intensity. Then I will join, and the distance, once again I will make use of position vector only here, or else I can use distance vector, but if it is meaningless because position vector means one of the coordinate is origin, right? So once again it is R vector and it is in the radial direction AR. This is the unit vector. So once again the formula turns out to be same as previous. So I want to write down the electric field intensity at the field point or where the test charge is placed. It is equal to the source of the field Q1 divided by 4 pi epsilon naught, the distance between the two charges, magnitude of R square into AR vector. Instead of making use of position vector, if I simply take R, the distance vector, and unit vector as AR, then I will rewrite the formula. Don't get confused with the notations. If you understand the concept, you can make use of, you should not be confused with the notations if you are clearly understood with the concept. So 4 pi epsilon naught R square, so simply I will write R square into AR vector. Okay, then let me, this field point is there, let me take the coordinates of the field point as X, Y and Z, right? Let me call this point as P of X, Y, Z, where I am placing the test charge. Then how to calculate R and AR, we'll see. So the distance vector R, actually it is a position vector, but let me call it as a distance vector. One of the point is origin. So X AX, X into AX plus Y into AY plus Z into AZ. And magnitude, how to find out? You know, under root of X square plus Y square plus Z square. That is the magnitude R you will get, the distance between source point and field point. Then the unit vector you already know. So AR vector is the vector R, distance vector, divided by its magnitude, right? So you can substitute later on in this formula, so that I will be getting. So we have done the analysis in rectangular coordinate system by placing the source point at the origin of the spherical coordinate system and the test charge away from the origin, anywhere in the space with respect to origin, right? I hope it is clear. If any doubts are there, you can unmute yourself and speak to me so that I will clarify immediately. Okay, next we'll see the same thing, electric field intensity due to point charge. We will change our analysis. See here. So the electric field intensity E for charge Q, which is located other than the origin. In the previous two cases, in the rectangular system and spherical coordinate system, we have placed the source point at the origin. But next here, we will shift the source point other than the origin, right? We will locate the source point other than the origin and we will see what formula I will be getting, and we will try to make use of the position vectors in order to write down the formula for electric field intensity, right? Okay, just I will I will take the help of the rectangular coordinate system, x-axis, y-axis and z-axis, and origin is here, but I will not place the source point here at the origin. Other than the origin means somewhere I will place it here. So let me call it as Q1, or simply Q also I can call it as. Okay, let me call it as Q only. And it is at some distance, that is, let me call it as source point R vector, position vector. Then this is the source point SP, and it is positively charged. And I want to find out, this is the source point, I want to find out what is electric field intensity at the field point. Let me consider the field point here, and I will place the test charge QT. Is it fine? Then already we know test charge, the magnitude will be always 1 coulombs. QT will be 1, right? 1 coulombs. No need to mention, always the test charge will be, means I want to find out what is electric field intensity at this point, means I should not place one more charge other than unity, right? Okay, then from origin, this field point, that is field point, it is located at some distance. Let me call it as let me take this as r dash, and for this field point let me take this as r, anywhere r dash or r, doesn't matter. Okay, then the distance vector from charge, okay, let me call it as q1. It will be easy for me to write down the distance vector r1 to t, and unit vector is a1t, right? Okay, then I want to write down this in terms of position vector. Then what is r1t, right? So we'll try to write it here. So these two sets, this plus this, should give me r, means what this should be, I want to get r, so minus r dash should come, right? So r vector minus r dash vector. So if I add these two sides, means triangle law of addition, this is one side tail to tip, another side tail to tip, right? So r dash plus r vector minus r dash vector, r dash will get cancelled. I am getting the third side, addition of the two sides, right? Means this is correct, what we have done. So r1t is nothing but, if I express in terms of position vector, I can write it as r minus r dash vector. Is it fine? Just to differentiate, I have taken it as r dash. Is it clear? Then the coordinates of source point, I here just I will be writing away, because if I write it there it will be confusing. So x dash, instead of calling simply x, y, z, I will call it as x dash, y dash, z dash, right? Then here I will call it as simply x, y, z, x, y, z. Means the coordinates of source point are x dash, y dash, z dash, and the coordinates of the field point are x, y, z, right? In order to differentiate, I have made use of these notations. Then we will try to write down the formula, what is electric field intensity. Here you can observe, already we know what is electric field intensity due to point charge, but here we have located the point charge other than the origin, and we are making use of position vectors, right? So the electric field intensity at the field point is given by, the source is q1 by 4 pi epsilon naught. The distance between source point to field point, I will make use of position vectors, already I told. So r vector, so magnitude of the distance square, right? So magnitude of r vector minus r dash, the distance square, into the unit vector, right? Unit vector means this is a distance vector, the vector divided by its magnitude. The vector is r vector minus r dash, this is a vector, divided by its magnitude. So this is the formula. Okay, previous to this I will write another formula so that you will understand this very clearly. So q1 by 4 pi epsilon naught, in terms of distance vector I can write it as r1t square into a1t, right? So how I got this formula, I am telling you. Q1 by 4 pi epsilon naught r1t. What is r1t in terms of position vector? R vector minus r dash vector. The same thing I have written. Now what is a1t? The vector r1t divided by its magnitude. The vector r1t is r vector minus r dash vector divided by its magnitude. Hence, we have realized the formula in terms of position vectors. So you should not get confused whether the charge is located at the origin or other than the origin, right? Anywhere in the space. So you should be very much clear with the concept. I hope you understood this. Okay, next, the electric field intensity E due to n number of point charges. This already we have seen, that is the force while studying the Coulomb's law, the force due to n number of point charges. The same way, if I want to find out the force at any point due to other charges, n number of charges, it will obey the principle of superposition. I can add the sum of all the forces acting on that particular point charge. So here we can make use of the same concept. Just I will draw the diagram and I will write down the formula directly, right? So this is the origin. So I will consider one point charge here plus q1, right? It is, let me take this distance as, this is the source point, right, which is generating the field. So for source point I will be making use of r dash, like this, right, r dash. The next I will consider one more charge. I can go on considering n number of charges, but I will restrict myself. I will put n equal to 2, means I will consider only 2 charges. N can be 3, 4 and so on, right? So I will consider one more charge plus q2, another source point. This is another source point, right? And it is at a distance. This is, let me call it as r1 dash, and here this I will call it as r2 dash. I will write it here, r2 dash. Dash indicates it is with respect to source point, that's all. Then I will consider one more point, field point. This is the field point, right? So from origin the field point is a distance, let me call it as simply r vector, right, r vector. Then I want to find out what is the electric field intensity at this point. Let me call this point as P, where field point is located, right? Okay, 1 minute, the board is not cooperating, wait for a minute, just, okay, fine, it is fine now. Okay, let me, we have located the field point at point P. Then I want to find out what is the electric field intensity at point P due to charge Q1. That is one thing. Let me call it as E1. Then what is the electric field intensity at point P due to charge Q2? Let me call it as E2. Then the total electric field intensity at point P acting due to the two charges Q1 and Q2 is E1 plus E2, right? I hope you understood this. So due to charge Q1, I will join it here. The electric field intensity I will call it as E1. Due to Q2, I will call it as E2. Then the total electric field intensity at point P is given by E total is equal to E1 plus E2. Yes, this is the formula. Call this as equation 1. Then we know how to find out E1 and E2. Let me write E1. So the source point here is Q1 by 4 pi epsilon naught, the distance between charge Q1 and point P. Let me call it as here, I will write here R1P, I will consider, right? So here R1P square into the unit vector is, let me call it as A12P. So A1P, I hope you got this, right? Similarly you can write E2 vector. Here the source point is Q2 now by 4 pi epsilon naught, the distance between Q2 and P, let me call it as R2P, just like R1P. I am not writing here directly, I am writing here R2P square into A2P, right? So calculate E1, calculate E2 and add them, you will get the total electric field intensity acting at point P due to the other charges. Here other charges are 2 charges, it can be a number of charges also. I hope you understood this. Okay, we will try to solve few numericals on the electric field intensity. Is it fine? Okay. This is the first numerical. Okay, before solving this, I will take up another problem. I will come back to this later. Okay, I will take this first because that is the principle of superposition. I don't start that problem first. Okay, fine. A charge of minus 0.3 microcoulomb is located at this point A. It is given in centimeters. We have to take care of the units also. And a second charge of 0.5 microcoulomb is located at point B. This is also in centimeter. Find E at the origin. Part A we will solve first. Part B we will see it later. So charge, let me call this charge as Q1. First charge. It is minus 0.3 microcoulomb. It is located at A of centimeter is there. What I will do, just I will convert it into meters. 25 into 10 power minus 2 means 10 power minus 2 means 0.25 I can write. I am converting it to meters. 0.25 comma, or else you can keep it in centimeters so that it will be easy for calculation also. Later on you can convert it. Okay, let it be. Anyhow, both are one and the same. Anyhow, you are making use of calculator to calculate. We are not doing it manually. So 0.25 comma minus 0.30 0.15. Now we have converted this in centimeters, meters, right? And second charge Q2 is there. It is 0.5 microcoulombs. It is at point B of minus 10 comma 8. Sorry, I should convert it into meters. So minus 10 means minus 0.10 comma 0.08. 8 centimeter means 0.08 meters. 12 centimeter means 0.12. I have converted it into meters. Please take care about this especially. Okay, now then in the part A what they have asked, I will solve only part A, you will solve part B, right? Anyone. So find E at the origin. I want to find out what is electric field intensity at origin. Let me call origin as 0, 0, 0. Okay, there are two charges. What is the electric field intensity? Let me, due to Q1, I will call the field intensity is E1. Due to Q2, so the total electric field intensity at the origin, E total, is equal to E1 plus E2. Call this as equation 1. We will try to draw the diagram so that it will be clear. So plus this is Q1 is here and it is minus 0.3 microcoulomb, minus 0.3 microcoulomb, and this is located at point A, at A. I am not writing the coordinates of A. And another point B, where charge Q2 is located, Q2, it is equal to 0.5 microcoulombs. It is located at point B. I am not writing the coordinates, already I have written here. Then I want to find out at the origin. Let me consider the origin here, whose coordinates are 0, 0, 0. Then what is the total electric field intensity? I want to find out, right? Due to Q1, I have called it as E1. Due to Q2, I have called it as E2. So the total electric field intensity at this origin is E1 plus E2. We have said. Next, we have to find out what is E1. Okay, let me take the help of the notation, right? This origin I have taken O. Fine. Let me take the position vectors, or A is there, right? Okay, let me take RA vector also, or some other notation, or else it is better. A is this, A is the coordinate and O is the coordinate. Let me write the distance vector as RA to O. No problem. If I write one of the point is origin, I note, but still I am writing RAO in the form of distance vector, and the unit vector is A to O. Right? This is source point to field point always. This is source point and this is field point. And another source point is at B. Is it clear? Okay. First we will find E1. E1 is E1 is the source point is Q1 by 4 pi epsilon naught, right? The distance is RAO square into the unit vector is AAO. Is it clear? Okay, we'll try to solve it. Yeah, if there are any common things I can do it later, but okay, let it be. Q1 by, okay, let it be. E1 I will find out. There are no common things, so let me do it separately. First let me find out RAO vector. RAO vector, actually it is a position vector, but I am writing in the form of distance vector. RA to O, right? One of the point is origin, right? The coordinates of, 1 minute, the sign will change, I think so. The coordinates of A are 0.25 comma minus 0.30 comma 15, right? Okay, this is source point, and direction is from, always the direction of the field should be from source point to field point, but since this is negative charge, right, so it will be reversed. But let me not worry, let me assume this direction and will continue. If it is opposite, we will get minus sign, that's all, right? Okay, RAO will find out. RA to O means the position vector, right? RA to O means if I make use of distance vector, so I will be getting minus 0.25 AX minus 0.30 AY. If I am getting minus means I just take the distance vector A to O, subtract the origin to this point A. So 0 minus 0.25 and 0 minus means this will become plus 0.3 and sorry, this is 0.15, not 15, 0.15. So minus 0.15 AZ vector. Then we'll try to find out the magnitude RAO. So I'll take the calculator. I hope you are also taking calculator. Under root of 0.25 square plus 0.3 square plus 0.15 square. So I am getting it as 0.418, the distance 0.418 is the magnitude. Then AAO. What is AAO? AAO is the vector RAO divided by its magnitude. So the vector RAO divided by its magnitude. Magnitude is RAO. Is it fine? So first we will try to find out E1 full, then we will think of E2. E1 vector is equal to, what is Q1? So this is the formula. I will call this as equation 2. Already one I have called this equation 2. So what is Q1? Q1 is minus 0.3 microcoulomb. Minus 0.3 into 10 power minus 6 divided by 4 into pi into epsilon naught is 8.854. We know this is a constant. 8.854 into 10 power minus 12 farad per meter, right? So it was in centimeter. We have converted these coordinates to meter because this constant is farad per meter. It is not farad per centimeter, right? So it is better to convert, right? Always at the initial stage only. Then what is RAO square? RAO is 0.418. 0.418 square into AAO. What is AAO? The vector RAO. What is vector RAO? I am writing here. The vector RAO is minus 0.25 AX plus 0.30 AY minus 0.15 AZ divided by its magnitude. Magnitude is 0.418. So we will calculate. I am taking the help of calculator here. First I will calculate this part, then I will multiply with the inner thing. First I will calculate this part, how much I will get, we'll see. Then I will multiply one by one. And this 0.418 I can take it out, right? This 0.418, right? So this 1 minute, my board has this 0.418. I will take it out and I will make it 0.418 cube, right? This 0.418, the denominator. So this is taken in this only. I am putting the arrow mark here for calculation. So minus I will leave it. I will not worry about minus. Yes, 10 power minus 6, that we will see later. 0.3 divided by 10 power minus 6 I am leaving. Later on we will see. 4 into pi into 8.854 to the power of 12 exponential minus 12 into 0.418 whole cube, 0.418 cube. Close this bracket. So this entire thing, what I am getting, I am writing 3.69 into 10 power 10, but in the numerator 10 power minus 6 is there, right? So what I am getting, I will write once again here. You can observe here what I am getting. I will write it somewhere here. 3.69 into 10 power 10 I am getting, but 10 power minus 6 I have not taken care. Now I am writing 10 power minus 6. Finally what I am getting, I will write 3.69 into 10 minus 6, it is 4, right? 10 power 10 into 10 power minus 6, add them, so 10 to the power of 4, this I will be getting. So this entire quantity I have to multiply with ax, I have to multiply with ay component, and I have to multiply with az, and final E1 vector I will be writing here. E1 vector is equal to, so just I will multiply 10 power 4, I will leave it right now. 3.69 into, one more thing I have forgot, minus sign is there here. So minus sign, this minus sign should be taken care. So I have to associate minus here, minus 3.69. I should not leave it. So minus 3.69 into first term is minus 0.25 into minus 0.25. What I am getting, I will write 10 power 4. I will write it at the last. I should not leave it. So I will put the bracket 0.9225 ax. Then next minus 0.369 into second term, ay component is 0.30, so I am getting minus 1.107, minus 1.107 ay. Then minus 0.369 is multiplied with minus 0.15, minus 0.15. So what I am getting, I am writing here plus 0.5535 az. 10 power 4 I have left, I will write it here, 10 power 4 into 10 power 4. 1 minute. 10 power 4 volt per meter. This is only E1. Similarly, I have to calculate E2 also, right? In the next slide, we will calculate E2. So this is E1. Then we'll go for E2. Sorry, I don't have space. So shall I go to previous slide, and I will do it here. Previous slide, it is anyhow blank. So now I will calculate E2. And just I will look at and I will write down the formula. For E2, the source is Q2 by 4 pi epsilon naught. We will see the distance between Q2 and this point O. Q2 is here, O is here. Let me call this distance vector as R BO. B is there, B2O, RBO, and unit vector is ABO. Hope this is clear to you people. So RBO square into ABO. This is the unit vector, right? So first we will try to find out the distance vector RBO. Okay, I have to go to the previous slide. 1 minute. Okay, point B is B2O, right? B is point B. Let me write the points here. Minus 0.1, comma 0.08, then 0.12. So B2O we have to subtract. So everything will be minus, will become plus. Instead of minus 0.1, it will become plus 0.1x. I will write it here, plus 0.1x, plus 0.1 ax. Next it is plus 0.08 means it will become minus 0.08 ay, minus 0.08 ay, minus 0.08 ay. The next third is plus 0.12, it will become minus 0.12, minus 0.12 az. Then find out the magnitude RBO, magnitude under root of, take the calculator, under root of 0.1 square plus 0.08 square plus 0.12 square, 0.12 square. So what I am getting? 0.175, 0.175. 4 is there, I am restricting here. Okay, we'll continue. E2 vector is equal to, so what is Q2? Q2 is, what they are given, Q2 is 0.5 microcoulomb. Let me write it, 0.5 microcoulomb. So okay, 1 minute, my board is once again not cooperating. 0.5 microcoulomb, micro means 10 power minus 6 divided by 4 into pi, 4 into pi into epsilon naught is 8.854 into 10 power minus 12 into RBO. RBO is 0.175, 0.175 square. Okay, I don't have space, I'll write it here. The unit vector ABO, ABO is equal to the vector RBO divided by its magnitude, 0.1 AX minus 0.08 yes, 0.08 AY minus 0.12 AZ divided by its magnitude, 0.175. Okay, first we will calculate this part, but 0.175 I will take it here and I will make it cube for calculation, then I will multiply, right? First, okay, I will take the calculator and I will find it. So in the numerator there is 0.5, 10 power minus 6 I will take care later, divided by 4 into shift pi into 8.854 okay, 10 power minus 12. I think I have made a mistake here in the previous, because while dividing, what has happened, this 10 power minus 12 exponential I have taken. I should have not taken this, because I have taken care that later. Let me verify later. Okay, we'll see it, what will happen. The slight mistake has happened here, let me check it later, because 10 power minus 6 is there. 10 power, okay, no, not a mistake, it's correct only, it's correct, no problem, it's correct. Okay, I'll take 8.854 into 10 power minus 12 exponential minus 12 into 0.175 cube. Okay, what I am getting I will write here. So I am getting this as 8.385 into 10 power 11, 10 power 11, but I have left 10 power minus 6 in the numerator. This also I should take care, right? Then into this entire quantity, this numerator, only this one, within whatever I am showing, this bracket should come here, then here, this I am writing here. 0.175 is already taken care, don't take this once again, right? So 8.35, 10, 11 minus 6, let me rewrite it, 8.385 into 10 power 11 minus 6, right? So how much I will get? 11 minus 6, it is 5, 10 power 5. So this thing is 0.1, I will write it here, 0.1 AX minus 0.08 AY minus 0.12 AZ. Just I'll multiply and I will write final E2 vector, what I am getting. Then I have to add E1 and E2, so that I will get the total electric field at the origin. So let me multiply 8.385 10 power 5 will take care later, into 0.1 first. So what I am getting, okay, just I will observe E1, what I am getting E1 here. E1 is 10 power 4 is there, so I will make it this also as 10 power 4, so that it will be easy for addition. So 10 power 4 means I can write this as 10 power 4, right? 10 power 1, I will multiply 10 means 83.85 into 10 power 4 it will become, right? Okay, next I will multiply it with, right, I have taken 10 power 5, 10 is this, 10 power 4 is left out, 10 we will multiply 83 point, now it is correct. 83.85 into 0.1 first term, so I am getting 8.385 AX, then minus second one, so 83.85 into 0.08, 0.08, write down what you are getting, 6.708 AY, then you multiply 83.85 into minus will be there anyhow, 0.12, 10 point, so minus as it is, 10.062 into 10 power 4. So below this I will write even also, so that I can add both of them. So I don't remember, just may have a look at it. 0.9225, 0.9225, 0.9225, 9225 AX. Next second term we will see, minus 1.107, minus 1.107 AY. Let me see the third term, plus 0.5535, 0.5535. I hope it is plus 0.5535. AZ I had to write here also, I missed AZ. AZ I should write here. Here is also AZ into 10 power 4. Let me check whether it is positive or negative. 0.5535. Yes, it is positive. Then we will add and we will get the total electric field E. Add E1 plus E2. E1 plus E2 will add one by one. The 10 power 4 will take care later. So first I will add 8.385, 8.385 plus 0.9225. So I am getting 9.3075, 9.3075 AX. Next we will add the components of Y, minus 6.708 minus 1.107. So I am getting minus 7.815 AY. Then third Z component we will add minus 10.062 plus 0.5535. So Z component we are adding, so minus 9.5085 AZ into 10 power 4 into 10 power 4 volt per meter is the practical unit. We will verify the answer. Let us see. What's the answer? Yes, you can see here they are expressed in kilo. Kilo means 10 power 3, but we have expressed in 10 power 4, right? If I express in kilo, the answer is same. 9.2 we are getting, correct? 9.2, 7.7 I think. 9.2, 7.7. Just let me verify. 9.2. Yes, 9.2 means 9.3. 7.8, they have got 7.7, no problem. Then last one minus 9.5. This is, let me check the sign, plus minus minus, let me check. And this is 9.5, let me check it. They should get 95 something. 95, 105 they got, no problem, because in the calculations they have taken fractional part, something like that, right? It will be, it's correct, right? The answer is verified. Similarly, you try to find out the part B. Part A I have already covered. Part B you try to solve it. If you won't get, then I will solve it. But you today only you solve it, right? I hope the time is 11:24. So I'll stop recording. And if any doubts you can address.